Hello everyone, I am Chetan from Sri Venkateshwara College of Engineering from Bangalore, and this is a subject of software engineering and project management. The topic is software requirements engineering over the federated environment in distributed software development process. Abstract. Different independent terms or organizations work together even across different locations to develop software. This step up makes gathering, analyzing, and validation requirements more efficient. The model is designed to be the flexible and aligned and encouraging and collaborated different uh, local development teams. Each team contributes its strength to build a strong software prototype. The model was tested on two examples: an e-commerce website and a learning management system. Both functional, how the system works, and non-functional, performance, the security, etc. requirements were evaluated. The model's efficiencies was measured using mean square error, mean absolute error, Pearson coefficient (PCC), and the model showed good performance with MSE values of 0.12 functions and 0.153 non-functional, and MAE values of 0.222 functional and 0.232 non-functional. Overall, the model handled the challenges of distributed software development efficiently, addressing both functional and non-functional needs. Introduction. Software engineering has significant evaluated in areas such as requirement engineering, faults localization, benchmarking, and dependency evaluations, with a notable shift toward distributed software development (DSD). Involves collaborations among geographically dispersed teams, which can introduce challenges but also offers new possibilities efficiently with the learning, federated learning. These approaches enhance scalability, privacy, and rapid development. A federated environment unfiles teams working on independent components of software, allowing a global model to hammers that requirements based on the needs of the each component. The model addressing the challenges of various requirements priorities across components while stimulating and development creation. Moreover, the federated environment helps secure sensitive data and risks like single point failures, but building and fault tolerance into the system. Research questions. RQ1: can the stimulated development of the components of the software prototype be the concur ever changing the software requirements? And the research question number two: the significance of the requirement would differ from the component of the software, and unfilled requirement weight has to be assessed for optimized priorities of the requirement in the global model. And the third question, the development uh, time and cost of the global model in the federated learning environment and better than the conventional DSD models. Literacy review. There are considered studies and distributed software development technology as the DSD would help a more efficient and scalable prototype in a much more cost efficient and secure the manner. This variety of locations also makes it possible for continuous development process, since teams in different time zones can work on the project continuously, which can also significantly reduce the development time. The study has outlined multi-criteria models of task assigned in distributed software development, highlighting the qualitative decision-making methods and identifying key assets and classification that could benefit future researchers. A study based on a highlight to software development in a distributed environment has a state aligned teams and face-to-face communications and collaborations, but the software development challenges this due to the temporal and cultural separations. And this is a structure of global. and building the global model. Data analyzing and findings. The data in the current study is determined based on the FR and NFR associated with the case studies being considered and initial future weights and further being considered based on their significance in the project functional requirements and considered highly significant and non-functional requirements are at the next level. Subsequently, the future weights are optimized using the future engineering mechanisms. Lower significance features do not mean that they can be ignored during the development process. Rather, they are given lesser initial weights and based on their impact on the development process, they are given more weightage over the iterations. Data analyzing and findings is all the components that are deserved to be of the prototype are considered as the functional requirement where the features can be made in the prototype. References and Hamad S. Naga Srinivasan and 2023 the software framework for intelligent security measurements and sensor data in the context of technology sensors and invest in understanding the issues of distributed software testing amid COVID-19 process and a self-attention based on the deep conventional neural networks for IoT network instructions detection. Conclusion. The study investigates the feasibility of using a federated learning based distributed software development model for rapid prototyping in Halleck software development by interacting two local models which uses sophisticated graduate and descent and ant colony optimization techniques into a global model. The study evaluates performance using functional and non-functional requirements from two case studies, an e-commerce website and a learning management system matrix such as MSE and MAE and person collaborations coefficients show the result. The study highlighting the need of future evaluations with more features and the matrix improved aggregation aggregations methods, adaptive learning strategies for non-independent data and better versions control to ensure model integrity in federated learning environments. Thank you.